Hello, today we'll do Cambridge IGCSE Additional Mathematics Syllabus Code 0606 May June 2025 Series Paper 2 Variant 1. Please make sure to pause the video before before I review the answers so that you can attempt yourself the question. So without further ado, let's crack on. Question 1. Question 1 given you a quadratic equation and want you to use completing the square to find the coordinates of the stationary point. So remember, for completing the square, we look at first the coefficient of the x term. So we want to see which square or perfect square will be able to make this into a 2x, right? So there will probably be x plus 1 square. It will be x squared plus 2x plus 1. So we want this x squared plus 2x. So we isolate x squared plus 2x. It will be equals to x plus 1 squared minus 1. So, alright, let's rewrite this. Right, this x squared plus 2x, I'll straight away rewrite it as x squared minus 1, then minus 3. So, altogether we get for our new expression in the completing the square form, y equals to x plus 1 minus 4. And try and compare it or recall with your the completing the square, what's the form, right? This form. So the stationary point will be a k and h. For in this case, our k is negative 1, right? Because it's positive inside, where k is supposed to be negative. So whatever is that's inside the bracket square, you just have to take the negative value. So our stationary point will occur at -1 and -4. Okay, so this gives us a hint for the next question where we need to sketch the curve. So first of all, we know for quadratic graph, if the a value here, the a coefficient in front of this square is positive, so it will be a smiley face graph, right? So in this case, it is a smiley face graph, and we know the stationary point occur at -1 and -4, so it will be somewhere in this third quadrant here. Next thing we need to know is the roots. So we need to factorize this up. So it's probably +3, -1, right? So you have -3 and 1 as a root. So let's try and sketch the shape first. Try to do a smooth curve, right? So here we have -3 and here we have 1. Of course, the stationary point which is a minimum point is -1 and -4. And then next one is our y-intercept. Y-intercept is just this term, the constant term, which is -3 here. Okay, so that will be important thing. Okay, the roots, the y-intercept, and the stationary point, please label. Okay. Next question is another quadratic expression given in terms of x. So it's given that this quadratic has roots which are real and distinct. Find the possible values of k. For real and distinct roots, try and recall what makes it as real and distinct is the discriminant. Right, discriminant has to be greater than 0, real and distinct. So if it's just real, if just asking for real roots, it can be equal to 0. But since they're asking for two different roots or distinct roots, the keyword here, it has to be greater than 0. So if you recall, discriminant b squared minus 4ac. I think it's not given in the formula sheet, right? Discriminant. So actually it's given. So the discriminant is whatever in the square root. Okay, because if there is a value here, then they will have a plus minus, so there will be two answers. If there's no value, if it's just 0, then it's just -b/2a. Well, if it's a negative value, so you have no real solutions, right? So here greater than 0. So our b value here is what? Is the whole thing. So 3k minus 2. A value here is 2. C is k. Right, so let's simplify this. Okay, up to here we got a quadratic equation in terms of k. Now we have to factorize it to get the critical values. So it's probably 9k. You have -2 and -2, right? Greater than 0. And this is a quadratic inequality. So how it looks like is we have a quadratic graph and we want to find the parts where it's greater than 0. Greater than 0 means above the x-axis. So which part above the x-axis is here and here. So the corresponding x values, it will be on the right and on the left. Right, so we need to find the critical values. Critical values. So we know our solution. Here will be 2 over 9 and here will be 2. So k is smaller than, right? Yeah, smaller than 2 over 9, or k is greater than 2. So these are the two possible sets of k values. Moving on, sports club has these following members: 5 runners, 4 swimmers, and 3 gymnasts. They stand in a straight line, and right, so if all the swimmers stand together, all the gymnasts stand together, and all the runners stand together, so how do we arrange it? So let's say they all stand together, right? So let's say if this is the runners, swimmers, and gymnasts. So the runners, if they all stand together, it means here we'll have 5 of them, and they standing in a line. I mean, the order matters, so it will just be 5 factorial. For swimmers, you will have 4 swimmers, so 4 factorial. Gymnasts, 3 factorial. Right, that's not all, because they also can be rearranged within each other. So like the runners can be first, then the gymnasts can be second, and the swimmers can be third. So we need to, or we can consider all of these 3 as one single item also. Right, so these 3 items can be rearranged where the order matters. So we need to multiply another 3 factorial to consider for that. So all this we multiply. After you multiply, okay, you should able to get 103,680. 4 members are selected for an event. Find the number of ways this can be done with at least 1 runner, 1 swimmer, and 1 gymnast. Okay, 1 runner, 1. Actually, okay. So 4 of these. So that means 3 already have runner, swimmer, and gymnast. So these are fixed. It cannot be, or yeah, it cannot be changed. Need at least 1 of each. And again, they are selected for an event, so I guess the order doesn't really matter because they are all going to the event anyway. Okay, so find the number of ways this can be done when at least 1 runner. Okay, so in the case, we need to consider 3 cases, I suppose. We need to consider the 4th person, whether it's a runner, a swimmer, or a gymnast, right? So again, the order doesn't matter, so in this case we'll use combinations. So for the first one, the 2 runners, out of how many runners? 5 runners, you pick 2. 5C2. Multiply. 4 swimmers, choose 1. 3 gymnasts, choose 1 again. So I'll leave that for now. I'll calculate it later. Second case, you have 1 runner, so 5 out of 5 runners you choose 1. Out of 4 swimmers you choose 2. And out of 3 gymnasts you choose 1. Lastly, 5 runners you choose 1. 4 swimmers you choose 1. 3 gymnasts you choose 2. So we can do the calculation. Okay, so all these 3 cases we just need to add them up. So total 270, right? You should be able to get 270. Right. Coordinate geometry question. So they are giving you 3 or 4 points on a Cartesian plane and 1 line equation, and given you that the bisector of line AB meets L at point E. Okay, so for all type of coordinate geometry question or vector question, it'll be a great help to just sketch the problem first. So I'll just do a sketch of Cartesian plane. Okay, then we have 3. We have 4 coordinates to plot. So A, let's say is somewhere here. -4, 3. B is 6, -9. So somewhere here. C is 15, 10. So all the way up here. Again, your sketch doesn't have to be accurate, just somewhat, okay, somewhat accurate. Okay, so this is roughly the sketch, and now we know that the perpendicular bisector of line AB, so I'll sketch line AB out. So maybe this is line AB, and the perpendicular bisector is from the middle and having a right angle. Okay, like that. Now it's saying what? The line L has this equation. So maybe it's going something like that. Okay, it is just a sketch. So line L meets this point or this perpendicular bisector at point E. And we want to find the um what's it called, the area of triangle CDE. What color have I used? So yellow. I'll use yellow to highlight the triangle. So we want to find the area of this triangle. Okay, so a good point to start is we have information of A and B. So let's try and find out line AB first. So the gradient of AB is change of y over change of x, negative 1.2. So the perpendicular gradient will be 1 over negative 1.2, or negative 5 over 6, positive 5 over 6. And then let's find the midpoint of AB. Midpoint. Right? The midpoint formula is just the average of the two coordinates. Alright, now that we have our midpoint, we can do the straight line equation to get the perpendicular bisector equation. So for perpendicular bisector, we know it's a straight line, y equals to 5 over 6 x plus c going through the midpoint of AB, right? 1, negative 3. So c should be negative 23 over 6, if I'm not mistaken. Yeah, and then the equation of line, yep, we got this. Now, now it's just a matter of finding point E, right? So point E, when it intersects this line L. So intersecting with line L, right? Intersecting with line L, we can equate these two equations, and then we solve for x. Okay, so solving for x, we get 7, and now we want to find the y coordinate. Right, y coordinate. So we substitute into the original equation. Okay, so our point E located, we have the coordinates 7 and 2. So K is not too far off the sketch, right? 7 and 2. Okay, now to deal with the area. So you can solely find the height or however you're used to doing it, but I'm going to use the matrix, you call it the determinant method or the shoelace method, as you might know. Okay, so area, you write out half and then the determinant of the three coordinates. So the x coordinate will be on top, y coordinate on the bottom. Then going on to the next coordinate, then point E, which is 7, 2. Then when you're doing this method, please make sure to go back to the original coordinate, which is 15, 10. And this modulus or this determinant it disregards the negative value. Going down, you multiply and you take the negative, right? Negative. Then going up, multiplying is positive. Okay, simplifying, you should able to get 80, and then the area will be 40 units squared. Right, moving on. Part 5. Given that y is a function, use calculus to approximate the change in y as x increases from pi over 3 to pi over 3 plus h, where h is small. Okay, so first of all, we are given the change, right? Immediately we can know the change of x. That's pi over 3 plus h minus pi over 3, which is just h. So what we are doing here actually is, let's say it's a curve. I don't know what type of curve this is. So let's say pi over 3 is here. And then I want to find, going just a very little bit to the right, which is the h value. As x changes by h, how much does the y change? So I'm just gonna take, to approximate it, you can take the gradient at that point, and then you multiply by the change of um what we call the change of x, which is h, so we can get the corresponding change of y. Okay, so to find that gradient, what we do is calculus, or in this case, take the derivative and evaluate it at pi over 3. So let's do that first. We can see that obviously it's a product of two functions, so we're gonna use the product rule here. So dy dx. First, I'm going to differentiate the 2x squared, which becomes 2x, and I'll leave the tangent. Right. Secondly, I'll differentiate the tangent. Tangent differentiate is become a secant square, right? And of course, the x square, I'm not differentiating it, I'll just leave it. And then for tangent, I need to differentiate whatever's inside the function also. So that will be x over 2 differentiated with respect to x, I'll get 1 over 2. Right, so this is my expression for dy dx. So we need to evaluate it when x is pi over 3 to get the gradient there. So substituting the values. Right. Oftentimes, in real life also, we just want the numerical value. So for this one, I did not ask us to get the exact value, so we can type in our calculator and make sure it's set to radian mode. Right, typing in your calculator, you should be able to get 1.94. And yeah, so now we do the small change. We know that change of y over change of x can be approximated as dy dx. So our change of y corresponding to the change of x will be dy dx multiplied by the change of x. In this case, change of x we already got as h, dy dx 1.94. So that will be our final answer. Okay. Question 6. Using an appropriate quadratic factorization, find the first three terms of the binomial expansion of this in the ascending powers of x. So we can try and notice it's slightly in the form where a plus b squared, a squared 2ab, b squared. Where a in this case is 3, right? 3x, sorry. And b is 4. Right, you can check 3x plus 4 squared, you get 9x squared plus 12x plus 4. So we can rewrite this, or to the power of 5. Okay, power of 5, we write it as 3x plus 4 squared, the whole thing to the power of 5. And as you can recall, this exponent rule, if you have something to the power and then you raise it to another exponent, the two exponents can multiply together. So in this case, 2 and 5 multiply, and I can get the exponent of 10. Now all we need to do is just expand with the binomial formula. So if you forget, the binomial formula is in the formula sheet, but okay, a plus b power of n, that will be the sum r equals to 0 to n of n choose r multiplied by a power of n minus r and b power of r. Right, this will be the binomial expansion formula. I think I've spotted the mistake here. The b value here should be 2 because 2 squared is 4. So all of the values here, okay, this 4 should be 2. Okay, so a careless mistake there. Okay, now we want it in ascending powers of x. So I'll write the 2 before the x in this case, so that the a is 2 power of 10, right? So first term, right, you'll just be 2 power of 10. Second term, 10 choose 1, 2 power of 9 multiplied by x. Third term, 10 choose 2, 2 power 8 x squared. The 3x, sorry, 3x. And 3x squared. Then plus dot dot dot. So we type this into the calculator. Right, as long as you're careful in typing this into your calculator, there shouldn't be any error, and this will be your final answer. Okay, next find the term independent of x in the expansion of this. Okay, so we have x power 2 at the denominator here and x power 4 at the numerator. We go ahead and write it as exponents first, so like that, right? So let's ignore their coefficients for now. I just want to see how the 2x, the two, the variable of x multiplies together. Which in this case, our a here is 6x to the power of negative 2, b is half x power of 4. But the coefficients, they don't really change they don't change how, whether the x will be independent or not. So I'm just going to look at the ones with the variable, and I'll ignore the combination. So how our thing is going to multiply is x power negative 2 to the power of n minus r multiplied together with, okay, our n in this case is 12 already, so we know that. 12 minus r multiplied with x power 4 power of r. So we look at exponents. Exponent you can multiply together when it's raised like that. So x power of negative 24 plus 2r multiplied x power of 4r. And same base, so the exponents can add together. Okay, so if we want the term independent of x, right, for independent of x, the power should be 0. Okay, so we set this to be 0, and hence we get r, the value is 3. Sorry, 4. Right, so we know it's the fifth term. When r equals to 4 means it's the fifth term, because obviously 0, it starts from 0. R starts from 0. So let's do the term or the expansion for the fifth term. Or when r equals to 4, 12, choose 4, and a in this case 6 power negative 2 power of 12 minus 4, which is 8, half x power 4 power 4. Power 2, sorry. Sorry, power 4, yeah, correct. Okay, when you expand it, make sure you include the 6 also, as well as the x power negative 2. Right, so conveniently, or this is what we have calculated, that the x power negative 16 and x power 16 cancels out. So all we need to do, just make sure you type the values into your calculator carefully, and you should be able to get 51,963,120 as the independent of x term, right? Question 7. A function f is defined by this exponent or exponential function. Sketch this fx and hence sketch inverse f. Okay, so let's first start with f. We know the shape of a e power negative x graph, it looks like that. And we know there is a vertical shift of 3 upwards. So let's just sketch the vertical shift first, or that's also considered as the asymptote for the graph, right? So we'll sketch the asymptote. Okay, y equals to 3, and then I'll sketch the shape of the f graph function f, right? It will look something like that. Remember, yeah. Right, try as much as possible, don't touch the asymptote with the function. And this will be labeled as fx. And what will be the y-intercept when x equals to 0? So this is 1. And 2 times 1 plus 3, that will be 5. So label the y-intercept. Next, let's go for the inverse function, right? So inverse, if you recall that it's a reflection of the original function in the line y equals to x. So that will be the mirror line. And how it will look, again, you will have a asymptote also. So the asymptote will be also reflected in the mirror line, which will be x equals to 3. Alright, so x equals to 3, it will come from here, meet here, and go this way. So reflected, right? Oh, maybe I can draw a bit nicer. Yeah, draw like nicely, a bit smooth. So the reflection, as long as it's somewhat reasonable, it doesn't have to be 100% accurate, right? Then we label as f inverse. Okay, and here also again label the intercept, there will be 5 also. Again as reflected. Okay, 5, 5 reflection. Okay, so there's the two graph, the mirror line, the two asymptotes. Your asymptotes, um, axis intercepts, and yeah, that's it. So we'll label the graph. Okay, so the function g is defined by this. Given that g inverse exists, find the expression for g inverse and state its domain. Okay, so we know that if we let gx equals to y, and x will be g inverse of y. So let's do the rearranging first. Okay, so now we got until this point. Always remember your final answer should be presented as g inverse x equals to a function in terms of x. So you just swap all the variables again. And then we're not done yet because we want to find its domain. Okay, so the domain for an inverse function is the range of its original function. Okay, and what's the range for this graph? You can see that the only variable is down here in the denominator of this fraction, and as x increases, this fraction will decrease, and it will get closer and closer to 2, but it will never get to 2 because it will get, this value will go very close to 0, but it will never reach 0. Okay, that's just a fundamental of mathematics. Right, so it will start from, okay, the domain is x greater or equal to 0, so at 0, you can, this one becomes 1, so at 0 it will be 2. Sorry, this one will be 2 minus 1, so at the intercept, there will be at 1. And then it will go closer and closer to 2, but it will never reach 2. So that's the behavior of the function. So what it means is the range for this, okay, we include 1 because the domain includes 0, so we include 1. But we do not include 2 because it's asymptotic at 2. It will go very, very close to 2, but it will never reach 2, as I mentioned just now. This e to the power of x will get very, very big. The denominator will get very big here, but it will never completely become 0. It will always have some residual value that is very small. So we do not consider 2 as being inclusive. And so therefore, the domain, the domain of G inverse is x. Bigger than equal to 1 and smaller than 2. That will be the domain. Okay, solve this equation for this interval. Okay, so we know Okay, we know that the solution only lies within this quadrant 1. And okay, so let's deal with this. I think a lot of people will be tempted to expand this, but I think let's not expand this because it's already perfectly in this form where something is in this form. Either one of this can be equal to 0. They will get a solution lah. So either this equals to 0 or cosine x equals to 0. Let's deal with this cotangent first. Cotangent, look at the third letter, that is t, so there's a reciprocal of tangent. So 3 over tangent here, 2 minus of this. So tangent x, we can isolate it, 3 over 2. Right, so I don't think there is a triangle for this, so we have to type it in your calculator, make sure it's in radian mode. Right, the basic angle you should be able to get is 0.983 radian. Yeah, actually we only need one answer, right? So because that's only exists in first quadrant, so x is this one already. From this we yield one answer only. Now for the second one, cosine x equals to 0, does this have a solution within the first quadrant? Cosine starts from 1 and it goes to 0 at pi over 2, and then it goes to negative or the minimum at pi, and it goes back up at pi 2 pi. Alright, so the solution for this will be x is pi over 2. So altogether, yeah, only two solutions. X equals to 0.983 or x equals to pi over 2. Two solutions only. Next, solve this equation where pi is in radians and theta is in radians and theta is within this range. So cosecant, let's rewrite it. Look at the third letter is s, so it's a reciprocal of sine. And 12 sine 2 theta plus 1. Okay, so let's multiply both sides by sine. Okay, after rearranging everything, you should get a quadratic equation in terms of sine 2 theta plus 1. And you should be able to factorize this. Okay, so after factorization, you should be able to get two different cases. Okay, so two different cases here. Now, let's try and draw this out. So 0, 2 pi, pi over 2, pi, 3 pi over 2. So the solution lies in three possible quadrant. Okay, so yeah, let's do this. I mean, this is -1 and this is 2 lah, around somewhere there. So in the first case, our sign is a positive value. So it exists in quadrant 1 and 2. So let's get the basic angle. Okay, I think let me just do this first. So theta is within this, and then theta plus 1, 2 theta plus 1. Okay, so 2 theta plus 1 will be between 5 and -1. So I can able to expand this even further. Okay, so 5 should be also around here. So all quadrants are basically exist. So yeah, basic angle, yeah, 0.253 radians for this case. So our possible angles, we get, first put 0.253 in the first quadrant, and then we go to the second quadrant. there will be pi minus 0.253. Then can we go one more? No, we can't. So only two values from here. Then we need to simplify further. Okay, so two values of data from here. Now we deal with the other one. So it's a negative, and it will exist in quadrant 3 and 4. Okay, so let's find the basic angle again first. Basic angle, I got 0.7297. Right, so 2 theta plus 1. The possible values can be, okay, for the third quadrant, it could be 0.7297 plus pi. In the fourth quadrant, it can be 2 pi minus 0.7297. Okay, now we go, yeah, I think that's all for going the positive side. Now we go the negative side, right? We turn the negative side, and we get, first of all, is a negative 0.7297. That's from the fourth quadrant. Then we go to the third quadrant. That will be a negative pi minus 0.7297. So altogether here, how many solutions we have? Okay, it looks like here, this one in quadrant 4 is exceeds 5 already. So this one exceeds 5, so we reject. So we reject the answer here. So end up here we only have three answers, right? So theta. Sorry, here also this one is less than -1 already. So we also reject this. So this one doesn't count. Okay, so altogether theta we only have 4 answers, which is -0.865, -0.374, positive 0.944, and 1.44. Okay, so 4 answers. All lengths in centimeters and angles are in radians. Okay, so a sector of a circle that being folded into a cone, and we're given the angle of the major sector and also the radius of the sector. So we want to find the curved surface area, which okay, we can use the what's it called, the formula, right? Half r squared theta, where theta is in radians. So half, and r is 15 squared, and theta 6 pi over 5. So altogether area 337.5 pi cm squared. And find the circumference of the circular top. So meaning this one, right? Or use a red color. This one. So this circumference is actually the same thing as just the arc length. Because why this green part AB being folded together? This part is AB. Okay. So to find the arc length, also again, we use the formula, which is r theta, and theta must be in radians, and r in this case 15 again, theta is 6 pi over 5, so 18 pi and cm. Hence find the radius of the circular top and the perpendicular height of the cone. Okay, we got, what do we got? We got circumference. So circumference, that will be 2 pi r and equals to 18 pi. So r equals to 9 cm. And okay, so we got this, maybe I use blue. 9 cm. Okay, the vertical height is what we want to find, right? The vertical height here. And also we got the slanted height, which is hypotenuse. So we actually can use the Pythagoras theorem, where the height will be the subtraction of the hypotenuse from the the radius squared, and that we get 12 cm. Okay, so far so good. Water is then poured into a cone. When the depth of the water is h, the radius is r. Find the expression of r in terms of h. So let's just look at it from the side view. Let's say we look at it from here. Okay, what we look at like is just a triangle. Okay, we're looking at directly from the side, and let's say there's water up to here, and let's say we take it's symmetrical in the middle lah, because it's a cone. What we know is that this is the radius, and we also know that this is the height. But let's say if it's not full or something, it's still a similar triangle situation where this is the same angle and this is the same angle also. So it's a similar triangle and we can use the ratio, right? So we know that r over h is a ratio which is constant because it's the same triangle. So r, we know the full radius is 9 and the full height there is 12, right? So r will be 3 over 4 of h from the ratio that we can construct here. Now water is poured into the cone at a constant rate at 27 cm cubed per second. So this is a dv dt. 27 right, poured into the cone, so it's a positive. So cm cubed per second units. Find the rate at which the depth of the water is rising when the depth of the water is 4. When height is 4, what do they want? The rate at which the depth is rising. So what is the dh dt at that point? Because yeah, the change of the height or the depth of the water, right? So from dv dt, how do we get dh dt? We need to use the chain rule. So dh dt, dh dv, then dv dt. dv dt we know. So what we left to find is dh dv that we don't know. Right, so we can start by writing out the volume of the cone. And like me, if you don't remember what's the equation for volume of a cone, yeah, it's provided in the formula. Volume of a cone, base area A and height h, 1 over 3. Area, the base area, okay, base area will be pi r squared, then h. Okay, conveniently, what we have done is we have written r as a function of h. So we can go ahead and substitute that into the function here also. Okay, so after simplifying, you should be able to get this v equals to 3 pi h cubed over 16. Okay, now v is just in terms of h. The r has been eliminated, and we can go ahead and take the derivative in terms of h immediately on both sides. So we get a dv dh, and it will be equal to 9 pi h squared over 16. So all we need to do is to evaluate it when h equals to 4, dv dh, when h equals to 4. That yields 9 pi. Right, now we know dv dh, we can find dh dv easily because it's just a reciprocal, right? That's 1 over dv dh, which will be 1 over 9 pi. So finally, we can use this relation, the chain rule. dh dv, dv dt equals to 1 over 9 pi multiplies with 27. So we have 3 over pi, finally. And the unit is cm per second. Alright, next. The particle P moves in a straight line. After t seconds passing point O, the acceleration is given by two functions. At t equals to 3, the velocity of p is 1 over 3 meters per second, and its displacement is negative 1 over 4 meters. Find the velocity of p when t is 4. Okay, right, they want us to find the velocity. Okay, velocity, we can find with the integral of the acceleration with respect to time. Alright, so we can use either one of these equations, I believe. Yeah, they should yield the same answer at t equals to 4. So we integrate t squared minus 2 in terms of dt, t cubed over 3 2t plus c. And that c, we know when 3 seconds, velocity at 3 seconds is negative 1 over 3. So c in this case is 10 over 3. And our velocity, okay, for the first 4 seconds, we have this equation. Alright. And at t equals to 4, you just substitute the value of t is 4. And our answer will be 10 meters per second. Okay, next, find the displacement of p from O when t is negative 4. So again, displacement, we need to integrate once more the velocity equation with respect to time. So we need to integrate this. Okay, so again, after we integrate, it's an indefinite integral, we add an arbitrary constant. And we can solve that using when given information, right? When t equals to 3, displacement is negative 1 over 4. 3, negative 1 over 4. So in this case, d is 12. And our velocity equation is presented as such. Now all we need to do again is substitute the value t equals to 4, and we get our answer of displacement of 4 meters. Okay, next question. Find the displacement of p from O when t is 10. Okay, is there a reason why they give okay so much space? Because we need to do the integration all over again using from here. Okay, we need to use this equation now because the first equation, it only applies from 0 to 4 seconds. So now we need to go from acceleration all the way to displacement again, and we need to integrate this one. So okay, velocity, again, integrate time, integrate acceleration respect to time, and it's a new equation this time. Now that I copy it, we just do the integration as usual. For the exponential, remain the same except you divide by the new power. Except you divide it by the derivative of the inside function, which 8 minus 2t, taken the derivative, you just get negative 2. So plus 5 over 2 e8 minus 2t, and add arbitrary constant. Okay, how do we solve for this arbitrary constant? We cannot use the same initial conditions that's been given to us by the question, because it does not suit the domain of the equation, right? We need to find where t equals to 4, and where does t equals to 4, we already found it with our solutions for part A lah. So part A, when t equals to 4, we know that v equals to 10, and when t equals to 4, we know that displacement is 4. We know these two information. So we know that v equals to 4 is 10, so we can solve for this constant. So e value here, able to get negative 68.5. And our velocity equation, the final one, will be this. Okay, next we need to find displacement again. Displacement, again will be the integral of velocity respect to time. We integrate this. Again, why this becomes a negative 5 over 4 here? Because you need to divide by the derivative of the inside function of the exponential. So 8 minus 2t differentiated, you get negative 2. So you divide by negative 2, 5 over 2 divided by negative 2, that's negative 5 over 4. 68.5, just add a t. Then another constant. So as we found in part A, we know that displacement when time is 4 is 4, 4 right? 4 meters. So using this information, we solve again. Alright, our final displacement equation will look like this, a bit messy, but that's the state that it's in. So we want to find when t equals to 10. Just substitute the value again. Okay, and we got the final answer. Displacement is 392.2 meters at 10 seconds. Okay, last question. A geometric progression has first term A and common ratio R, where R is greater than 0. The sum of the second and third terms is 168. Okay, so T2 plus T3, that's 168. Sum of the fourth and fifth terms is 94.5. Find the sixth term of the progression. Okay, geometric progression, so the formula, okay, geometric progression. This one, right? This one. AR n minus 1. So we don't know what's R, we don't know what's A. All we can do is just substitute the n values. So for T2 plus T3, so AR power of 1 plus AR power 2 equals 168. And for T4 and T5, AR power 3, AR power 4, 94.5. Let's do some algebraic manipulation. Yeah, we can factorize out the AR from both of these equations actually, so it look like that. Then this one also we factorize AR power of what? 3. So 1 plus R again. And then what I'm gonna do is I label 1 and 2, and I'm going to use the second equation divided by first equation. Alright, so 1 plus R cancels, and this. So we have just R squared equals to whatever this value is. So 94.5 divided by 8.5625. So we take the square root. We know that R is greater than 0 already, so we ignore the negative square root and we get 0.75. Okay, good. Okay, good. So we got R. Now we find A. Okay, we find A. So back into equation 1, we substitute R is 0.75. A we are able to get as 128. So for the sixth term, 128 times 0.75 to the power of 5. And we can get 30.375. Okay. Part B, find the sum to infinity of the progression. Sum to infinity only exists when the modulus of R is less than 1, so in this case it's fulfilled that requirement. And if you forget the formula, okay, look here. S infinity A over 1 minus R. So S infinite A in this case 128, 1 minus 0.75. Okay, so 128 times 4, 512. That will be the sum to infinity. Alright, hope you learned something. All the best in your studies. Thanks for watching.